Assalamu alaikum and good day. My name is Rashid Musa Rishum and today I will be presenting my project. The title of my project is a smart parking system. The focus of this project is to design a smart parking system that detects the occupants of parking spaces in real time using an ultrasonic sensor. The system aims to reduce traffic congestion, save fuel, and help drivers find parking faster by providing accurate and instant parking availability information. Background: in many cities and campuses, drivers spend a lot of time searching for available parking spaces. In this necessary searching increases traffic congestion, wastes fuel, and creates stress for drivers. A smart parking system is designed to solve this problem. It is uses sensor to detect whether a parking slot is empty or occupied and sends this information to drivers in real time through a mobile application. Problem statement: the main problem is that drivers waste a lot of time looking for empty parking spaces. This leads to more traffic jams, higher fuel consumption, and increased carbon emissions. A more efficient method is needed to provide real-time parking availability. Objective: the objective of this project is to monitor each parking spot in real time and provide updated information to drivers through a mobile app. This allows drivers to quickly find available spaces, save time, reduce congestion, and improve parking efficiency. Measured variable: the measured variable in this system is the presence or absence of vehicle. The sensor detects whether a car is occupying a parking slot or not. Sensor choice: to choose the best sensor, I compared in three different options. Sensor 1, ultrasonic sensor; sensor 2, passive infrared; sensor 3, magnetic reed switch. In terms of criteria, the range, accuracy, durability, power, and the cost. The range of sensor 1 is 21 to 600 centimeter. Sensor 2 is 0 meter to 7 centimeter, and sensor 3 is 0 less than 1.5 centimeter. In terms of accuracy, sensor 1 is plus minus 1 centimeter. In sensor 2 is the reliability of motion detection. In sensor 3, very high. In terms of durability, in sensor 1, sensor wire waterproof, model not waterproof. In sensor 2 is not waterproof. In sensor 3, sealed glass tube filled with uh, inert gas. Uh, in power, sensor 1 is 3 to 5.5 volt and 80 millimeter ampere. In sensor 2 is 5 volt to 20 volt and the current is 65 millimeter ampere. In sensor 3 is 3.3 to 5 volt and the current is 15 milliampere. In terms of cost, sensor 1 is 590 to 630 ringgit, and sensor 2 is 4 to 90 and 890 ringgit. In sensor 3 is 2 to 6 ringgit. Chosen sensor after comparison. After comparing all three sensors, the ultrasonic sensor is selected for the smart parking system. The reason for selection is it has a long and accurate detection range 21 and 600 centimeter, which is suitable for detecting cars in a parking spot. It provides very good accuracy plus minus 1 centimeter, making it reliable for measuring distance to a vehicle. It has partial waterproof, which means it can work better in outdoor parking areas compared to other sensors. Its power consumption is moderate and acceptable for air-to-bathed system. The cost is still reasonable for prototype and full scaling. Uh, in terms of ultrasonic sensors application is level measurement and smart home automation. How the sensor related to the project. and the current range. This range is ideal because it fully covers the vertical height of a standard parking bag. It also allows us to mount the sensor flexibly, either on poles or above parking spaces. Most importantly, it enables the system to reliably distinguish between an empty space and an occupied one. Higher coherence. It makes the system less prone to error even with the small obstructions. It can detect small changes in distance when a vehicle enters or leaves a bar. This directly translates into clear and reliable occupancy status, allowing our mobile app and LCD display to give real-time updates without the false alarms. Durability and power efficiency. It has a waterproof sensing element which is important because parking areas are exposed to outdoor conditions. It is ensure effective wave transmission so the sensor perform constantly even in a challenging environment. Prototype construction. To build the smart parking prototype, the process was done step by step using hardware, mechanical parts, and the software. Hardware assembly. Ultrasonic sensors were placed at the H slot and an SP32 read all sensor data. A servo-motor acted as the gate and the LCD display showed available spaces. All components were powered with a 5-volt supply. Mechanical construction. A base platform was created to arrange parking slots and a 3D printed chassis protected the sensors. The servo gate and the control unit were securely mounted for stable operation. Software integration. The SP32 was programmed to read sensor data and update parking status. The system was connected to the Blink app for real-time monitoring and the LCD displayed available slots. Result is sensor detected vehicle accurately giving reliable readings. LCD and the blank lab updated in real time, showing changes with the seconds. Gate opened and closed correctly depending on the parking availability. Data transmission was stable and fast with no connection issues. The smart parking prototype performed reliably. Sensors detected vehicles accurately in both the LCD and the mobile app updated instantly. The gate operated correctly based on parking availability and the communication with blank remained stable. Overall, the system successfully demonstrated efficient smart parking operation. Finally, I would like to say that this smart parking system project demonstrates how sensor technology can help reduce time drivers spend searching for parking, low fuel consumption, and easy traffic congestion. By comparing different sensors, the ultrasonic sensor was chosen as the most accurate, reliable, and cost-effective option for detecting vehicle presence in real time. This system supports smarter, faster, and more efficient parking for modern cities. Thank you.